Okay, why don't we get started? Good morning. And today's speaker is Tom Silsby from the MSU water treatment plant. And Tom is the head operator, superintendent, supervisor. I'm not sure. I change your title periodically.
It's officially it's skilled trade supervisor.
All right. And he is the operator in charge at the treatment plant. And he's going to talk to us today about the MSU treatment plant, how they've operated, and kind of where they've gotten to the point today. So welcome, Tom. Thank you. And I appreciate you being willing to do this today.
Well, you're welcome. I'm glad to be here. It's been kind of new to Michigan State University. I started in March, just before the COVID shutdown. I was in the office for a week and then went home for 3 weeks, and now I'm back. And then since then, I've been back. So to start off with, there we go. This is the distribution system or operating area that MSU maintains. You see the green, the North Campus, that's what is now the treated distribution system from the water treatment plant. The farms distribution system is where all the wells are located, and we still have customers on that well system. So for lack of better terms, we have two systems. A little more detailed map, site locations, well locations and sample sites that we draw samples from around the campus. We have to do water quality parameters 2 times a month. So every other week we're drawing water quality parameters and back T samples from around the campus and in both systems. This is the ArcGIS of the water mains that supply the water treatment plant and are the distribution system that some of it is new that surrounds the plant and where the tower is fed, and then the tower is supplies the system. This is a picture of the old facility that was operated for more than 50 years. This was the reservoir consisted of a 1 million gallon underground storage tank and 4 high service pumps to maintain pressure on the system. This is pictures of the pilot study done in 2017 to determine what the incoming water quality would be, and to study what treatment technique to apply to design the plant to. General design of the water treatment plant. We have 4 horizontal filters with 2 sections each. We're able to manage each filter or each section in each cell. Here's a 3D view of what's on the treatment floor. The green pipe is the inflow from the well system. We can feed from either end of it, of the building, and distribute to the filter cells from that. Generally, we're set up to run from what would be the right side of the screen into the center plenum to distribute to the filter cells. And then the blue pipe along the bottom is where the finished water is, the effluent finished water is pumped through the system to the tower. Here's what the actual internal looks like. The media design for each filter is starts off with a concrete base in the bottom, and then air diffusers push up through gravel, then a sand layer, and anthracite on top. Front view of a filter cell. It shows the valving. All of those valves are electric motorized valves and are adjusted to throttle flow through the filter. There we go. This is a screenshot of our Scada, one of the screen where we're able to make changes in the Scada system to turn to bring filters on or offline, control backwash, and monitor chemical application and flow through the plant, along with water height in the tower. The view on the left is a picture from the sodium hypochlorite or bleach room. There we have redundancy, backup pump system. So there is two pumps for pre-filter application and 2 pumps for post-filter application. Hydrous manganese oxide. That chemical room is kind of the special sauce that we make for the oxidation process of the HMO. I don't know if everybody's familiar with how HMO comes to be. We have sodium permanganate and manganese oxide are combined in a mixing tank. It has to age for 24 hours before it's the catalytic action that those two chemicals go through, and then we have HMO. We mix primarily the first batch at 10%, and then for application, we for the date or for the holding tank or storage tank, and then for the date tank, we transfer into what becomes a 1% solution, and then similar to the sodium hypochlorite, we have 2 pumps for redundancy, and one injects into a carrier water stream, which is then injected at the pre-filter. This is a couple of random shots from our laboratory. We monitor for process control and compliance monitoring that we need to do for our permit. This is design specs for the new water tower. The total overall height is just above 160 feet. 120 feet to the bottom of the bowl, and a capacity of 2 million gallons. Here we have a little video of from the construction of the tower and the plant. And this is a video of them, more direct video of raising the bowl to the top of the tank. Yeah. Excuse the technical difficulties. Okay, pressure filtration. We have 4 horizontal filters. They're a selectable alternative. Chemical oxidation with sodium hypochlorite. Design capacity for the plant as it's presently configured is 7 million gallons per day. 4 dual cell horizontal pressure filters carry the load at 4 gallon per minute of square foot loading rate on the media with 18 inches of sand and 12 inches of anthracite on top. And expandable, there's room currently to put a 5th filter in to expand it to 8.8 million gallons a day. This is just a glamour shot of the plant and tower as they sit today. Currently, we're performing a corrosion study with at 3 different rates of application to determine what phosphate and at what rate we need to apply it to bring our corrosion program into compliance or to be optimized. We are applying a phosphate mixture of 70% orthophosphate, 30% polyphosphate, and applying at the 3 different rates of 1 part per million, 1.5 part per million, and I believe it's 2.5 part per million. Our chemical supplier is operating this. He had manufactured the test racks and and he's working with his parent company to do the testing of the coupons or weighing of the coupons and operating the test. There's also 2 sites out in the 3 sites out in the distribution system where we're monitoring corrosion and currently applying that same orthophosphate mixture to the system from since August 26th from our go live, and we're currently in the middle of a round of lead and copper testing to monitor that for that it's been state mandated. It's kind of a dark video, but this is what the filter backwash into there's an open basin in the end of the filter room. Yeah. So it's kind of dark, but basically that's where the backwash is deposited into the sanitary sewer. This is the top of the tower, the Goodyear Blimp shot for when they come to town and do ESPN game day or for a basketball game. Another shot looking north into the campus. This was this is a video taken 2 weeks ago when we had to do an internal inspection on the tank. There was a ROV inserted into the tank, and the inspection was done for the paint warranty. Another shot looking south in front of the football practice complex. And another one of the pictures for publicity. And that concludes the slideshow part of the of our presentation. I guess we're open for questions.
Tom, I have one question that was in the chat, and maybe if
Okay.
you can go back to the schematic of the filter, it'll probably help. So the question is, in terms of the pressure gradient, is do you have to reverse the pressure gradient to backwash the filter? So maybe if you can just, maybe with the cursor, just explain how backwashing works.
Okay. The influent is shut off, and valves to the from the light blue to the brown are opened, and the flow is reversed through the filter. Gray pipe, it comes out in brown pipe for waste. And there is two different cycles. If you have it, there's a low flow cycle, and there's.
So it's very similar to what we looked at with a gravity filter. So it's the same thing that what you're doing. You see the under drain there. So just as with a gravity filter, you're pumping water up. Now through that filter, you see you've got the backwash collection. So just as you're designing in the homework you're working on right now, you're designing your backwash trough. You see it's doing the same thing. There is a backwash trough. So it's going to fluidize that bed, and then it will collect water in the backwash trough. And notice the colors on the pipes. The pipes are all color coded. So the brown would be your filter backwash.
Correct.
Other questions? Feel free to mute yourself. And this one thing to mention is this is for iron and manganese removal. It is not for hardness removal. So there is no hardness removal in the plant. The calcium, magnesium levels leaving the plant will be roughly the same as when they enter the plant. And I presume the residence halls that do soften water at the point of entry will continue to soften water for
You are correct.
removal.
Yes, you are correct. The residence halls are, I've been informed that the residence halls are 100% softened hot and cold water. Other buildings where there's research or classrooms, the hot water is only.
Other questions? Typical hardness of the water, Tom?
430 to 450 parts per million total hardness.
And that's as calcium carbonate.
Yes. It all depends on which wells we have running. there's 16 wells in the system, and it's basically 4 square miles of land mass. It's on the larger side for a well field.
So Tom, there was, I believe, one well a few years ago that had high concentrations of, believe it was radium, it was alpha.
This is radium 226 and 228.
So have they that's still shut off, right?
Yes, well 27 has been offline for a period of years. We're actually working on water softeners is also an approved treatment technique for removing radium. And in the farm distribution system at point of use, we've got about 90% coverage with softeners now, and we're working on being able to get total coverage so there'll be no notification and approval from Eagle to be able to re-equip that well and put it back into production. And that way we won't be we won't have to worry about radium contamination in anybody getting a shot of radium.
There's a question about testing for PFAS.
Yes, every well they put in just last month a mandatory every entry point to the distribution system shall be tested for PFAS. Currently we are on a yearly test. Any of the testing that we've done before has not shown any PFAS. We have all of the testing has come back non-detect.
Another question, how shallow or deep are the wells?
The majority of the wells are 320 foot to 400 feet deep. You get much deeper than 400 feet in this area and you get into salt water.
Other questions? Tom, number of students in the class are also in my lab class, which this afternoon we will be talking about distribution system monitoring.
Okay.
So maybe you could just, for the benefit of those that are in both classes, maybe you could just talk a little bit about what the required monitoring is, how often you have to monitor. If you find, for instance, E. coli, what happens? What do you know? So just kind of how you have to deal with how often you monitor, and if there's violations, how you have to deal with it.
Sure. Currently, we are under mandate from Eagle to, because of the size of our system in the North Campus area, we monitor 10 sites spread out over the system to fairly represent the system. We take the bacteriological sample from each of these 10 sites twice a month, every 2 weeks. Along with that, we draw what we call a water quality model sample, and we perform water quality tests, and from that it is those tests are being monitored and to be able to predict corrosion control, and that also goes into determining what blend of phosphate that we use and the application rate. The water quality tests that we currently do are iron, iron, calcium, manganese, pH, uh, chlorine free in total, and fluoride, and sulfate, and chloride.
So, and then at the plant, you're monitoring,
All of those parameters also,
but you're doing those on a more regular basis, correct?
every day.
Okay.
And then that's done for process control, to look for breakthrough in the filters, and to that's also on the days that we pull water quality parameters. That's the 11th site.
Could you maybe just talk really briefly about how did you pick the 10 sites?
Well, it was kind of a group meeting with all the operators, and they having experience with the system. We had proposed sites. We went out and visited the sites, qualified them as to being able to easily access them, and to spread them out as a fair representation of the distribution system. And then we submitted that to Eagle for approval, and there was they accepted our choices.
So was there any, because I talked about this Monday, was there any attempt to look at dead ends, basically dead ends, or use any of the hydraulic modeling to determine those 10 sites?
Yes, that was part of the criteria. We Oh, that was part of the criteria, was to choose sites that were on dead end lines and also looped in for comparison. We, to my knowledge, we haven't had any bacteriological samples come back for even for positive. And then if one were to come back positive, we've got sites within five connections one way or another of that site, where you go upstream, downstream, and test for that. And then you would resample your site that failed to determine possible contamination or whether it was a false positive.
Thank you. So we have another question of why do some of the buildings only soften the hot water?
Cost. The hot water is only softened because of there's nobody living in the building, number one, and number two, the softened water, when you heat our quality water, the calcium drops out in the hot water heater and shortens the life of the hot water heater.
So if you remember, we talked about temporary hardness, permanent hardness. So that temporary hardness is going to precipitate in the hot water heater. So that protects, or in the hot water pipes. So that helps to protect those pipes. And actually, even in a home, you're better off only softening the hot water line. It protects the hot water heater, it protects your hot water piping, but it doesn't increase the salt content of your cold water, which is what you should be drinking. And for those that are on low salt diets, you don't want to increase the salt content of your drinking water. So even for a home water heater, most actually are plumbed to treat both and to soften both. But from a health perspective, it's actually better just to soften the hot water.
And if I could add to that, there is one of my previous jobs in life, I used to install home soft water systems. And about when one was installed, so it treated the whole house, usually an extra line was run to the kitchen sink.
Thank you. Other questions? If there are no other questions, let's thank Tom for his time, both putting together the presentation, which he did especially for us, and spending this morning with us.
Glad to do it. Thank you.
And you're getting lots of thanks in the chats.
Good. I appreciate the opportunity to pass on what little we have here, but to let, part of our job now is to promote what we have and hope that better water quality is noticed and appreciated across campus.